All right, well, here we go. Here's a little video about section 2.1, average rate of change. Okay, so like we talked about in class, get this in your head. F of B minus F of A over B minus A. So what I want you to think about though is just think about just slope. Y2 minus Y1 over X2 minus X1. That's the rate of change of a line, right? Well, just use fancy symbols. Y2 minus Y1. Okay, so here's this example. It says determine the average rate of change for this function on this interval. Okay, so we just need to find this using here's A, here's B. So here's F of B minus F of A over B minus A. And just plug those in. Plug in 2 to the function. Well, that'd be 2 to the fourth plus 2 minus, and then make sure you use parentheses here because it's minus this whole thing. So plug in negative 3. So minus negative 3 to the fourth plus negative 3. And then do. That equals 18. That's 78. 18 minus 78 is negative 60, or 5 is negative 12. What does that mean, negative 12? We'll look over here. Here's a crude sketch of this function. Well, here's 2 comma 18. Here's negative 3 comma 78. Hey, guess what the slope between these two lines is? Negative 12. Okay, number 4. I can just pause this video, rewind, go back. You don't have to raise your hand and say, what? Just pause and go back. Okay, this one here. Ding, 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 ding. Well, here's B, here's A, B, A, B, A, B, A. So just plug in F of B minus F of A, F of B minus F of A, F of B minus F of da. So here's this function. So for this one here, from the interval 1 to 3, so what's the function at 3 minus the function at 1 divided by 3 minus 1. So put this number here, 3 minus 1 is 2, etc. So just follow those through. Just pull the numbers from the table. Like D, it says the interval 3 to 4. So 17.6 minus 10.5 over 4 minus 3. And that's what that is. Okay, the next page here, just kind of more details about this. Now what we're leading to is this picture here. What we're leading toward is, yeah, let's find the slope of this line. But instead of just 2 points, let's define this other point as being a certain distance away from an initial point. In this case, let's say the point Q is 0.6 units away from P. Okay, well, what's the x-coordinate then? Well, I would take 4.75 plus 0.6. Well, what's the y value? Well, I need to plug that into the function. So this is the function c of x. If I plug in 4.75 plus 0.6 to the function, well, that gives me, that's this 5.35, 37, 47. Okay. So then, here's f of b minus f of a over b minus a. So here's f of b minus f of a over b minus a. And this difference between these two is 0.6. But what we're going to lead toward is, instead of 0.6, what if I wanted, 0.2 or 1 or 0.7? Well, let's just make this some variable, and we're going to call that h. So h is how far we're going to move away from this initial point. Okay, so where's the x-coordinate? Well, it's 4.75 plus h, right? So just move over. Well, what's the y-coordinate? We'll plug that number into the function. So take 4.75 plus h and plug it into the function. Well, then the average rate of change is, well, here's y2 minus y1 over x2 minus x1. So c of 4.75 plus h minus c of 4.75 over h. And so let's do that here. Let's say we're talking about this function, y equals x squared, and they've just graphed a portion of it. Normally, y equals x squared, if we had the whole thing, it would, bad graph, oh my gosh. That's getting a little better, golly, I shouldn't have done that. But anyway, normally y equals x squared looks like that, so this is just a portion of it. Okay, so how about x equals 3? Well, so then this is x equals 3. Where's this point here? Well, 3 plus h is the x. What's the y value? Plug in 3 plus h to the function. So that'd be 3 plus h squared. So here's f of 3 plus h minus f of 3 over h. And remember, because that's the distance. X2 minus x1 is h, right? The distance between these two. The distance in the y direction is the y2 minus y1. And then, yeah, that'd just be 3 plus h squared minus 9 over h. And that says fill in the table of values for different values of h. So what you want to do is just take this and let's look what happens. Hey, what about this average rate of change as h approaches 0? Now at 0, it'd be undefined, right? Because if h was 0, this would be 3 plus 0 is 3 squared is 9. 9 minus 9 is 0. 0 is 0. And what's 0 divided by 0? Try something else. So at 0 is undefined. But what about the limit? As it gets closer and closer to 0, is this approaching something? 6.1, 6.01, 6.001. What about from the other side? If the limit exists, the sided limits have to agree. So what about from the right? Negative 0.1, are these approaching something? 5.999, 6.001. Hey, it looks like it's 6. So that's the idea here. We're trying to take the average rate of change and make the distance between it approach 0. And the last one here, just let's go look at this. It says simplify, so just do this one quick. Plug in x plus h to the function. And we gotta remember how to square things. Square x plus h, that's x squared, h squared, and 2xh. Distribute the 3, combine like terms. So that's this part. Then in the numerator, we want this thing, so that's here, minus the function. Just don't forget these parentheses. So minus this, minus that. So here's this from above here. Let's see. So here's this here, minus the function. But just don't forget distribute this negative. And now look at this. Here's plus 3x squared minus 3x squared. Here's plus 2 minus 2. Cancel. So this cancels with this. This cancels with this. Just leaving these two things. And then divided by h. And look, these both have an h in common. So we can factor that out. And then these cancel. We'll be left with 6x plus 3h. And this will always happen when these kind of problems, everything that's left over has an h in it, so we can factor out h and cancel this discontinuity, which we know as a limit, the limit exists and it looks like what's left over. And so as h approaches 0, what does 6x plus 3h approach? Well, 3 times 0 approaches 0, so this is just 6x. And that's video number 1. All right.